To process data with Python, you need to be familiar with several basic Python data types. The previous video discussed the first three topics listed here: Python numerical data types, string data types, and string operations. Standard mathematical operations, addition, subtraction, multiplication, division, and so forth, can be performed on numerical data types, such as integers and floats. Strings, which are sets of characters surrounded by quotation marks, also have associated operations such as indexing, concatenation, slicing, checking for membership in, and finding their length. Most Python data types, including strings, also have a set of methods associated with them. String methods is the first topic in this video. After that, string formatting is discussed. There are a number of functions associated with strings. We call them string methods. There is a link to the string documentation over here. There are quite a few methods listed for strings, and this is a description of what each one does. Capitalize, return a copy of the string with only its first character capitalized. Here are a few examples of how you might use these methods. To use the methods, you have to use an object.method format. So here we have an object.method followed by the arguments. And this example, we want to get the lowercase version of Parrot, bird.lower, and then there aren't any arguments. We have to put parentheses. It's not like certain languages that allow you to just omit the parentheses when you have no arguments. So we put the parentheses to finish, to show that it's a method that we're calling. And when we print out the value that it has returned to us, we get all lowercase Parrot. This method, bird.replace, replaces the P in Parrot with a C, so we get carrot. Can you guess what the last method is doing? State.count is returning a count of the number of those strings that are found within the string. You can do more than one letter substring. So this first one has no arguments, the second one has 2 arguments, the third example has 3 arguments. It varies depending on the method that you are using. String methods are so important that we're going to spend some additional time on them. I snuck these slides in here retroactively, so the slide numbering may be a little wonky. Please pretend like you didn't notice. Proficient programmers have at least a handful of string methods memorized and are broadly aware of the other kinds of string methods that are available. If you're not sure what a particular string method does, you can usually figure it out just by trying it on an example. The examples shown here assume the variable bird has been created as shown near the top of this slide. Bird equals, quote, parrot likes you, end quote. Now, since there are so many methods to start to become familiar with, it helps to group them by functionality. String methods can be grouped roughly into a set of groups that are shown on the next 2 slides. There are several methods for changing the case. For example, swap case makes it down and then up, the opposite of what you had here. It swaps it around. Bird.upper returns Parrot likes you, all in capital. There are is it one of these methods? Is alnum stands for alphanumeric, and it is. It's alpha. A string that would be non-alphanumeric would be something like this that has special characters in it. Notice you wanted to say object.method, and the object in front of the dot can be a string variable that you've set up beforehand, like Parrot likes you, and as we've done here, bird.is alnum. But it can also be a string literal. So you can say, quote, the string that I have in here, dot is alnum, and you get false. I'm using this notation a little bit like they use it in the help, with the arrow showing what would be returned to the right of the arrow, and the function call on the left of the arrow. Notice that 2.34.isDigit returns false, but 234 returns true. So you can't have any other characters, not even a decimal in there. It's looking for the digits, the numeric digits only. Bird.isLower is false. All of these, is space, title, is upper. I've given some examples for when it would be true over here. You can see what's going on. This one is the one that's kind of interesting. So is space can be only blanks, or it can be escape sequences that are translated into white space. So remember that the /n is translated to a new line, and that the /t is translated to a tab. So this is new line, tab, tab, some space, new line. Notice what a title looks like. It's got upper first letters. Then we have several methods that are to do with position or presence of substrings. In this example, we're finding the letter O, and that returns a 4. So if we say find O, we get a 4 because it's zero-based indexing, and it gives us the first occurrence of that value, of that substring, the beginning of the first occurrence of that substring. Notice that if you call the function with something that is not in there, you will get a -1 to indicate that it's not been found for the find function. And the index function does almost exactly the same thing. It gives you the first position of the first letter of the substring wherever it's found. So this is again found at 4 because OT is found starting at 4. But the index function doesn't, it throws an error if you try to call it on something that is not, a substring that is not found within the string. A substring is just a shorter string that's inside of a string. Bird.starts with sounds just like it is. It checks if something starts with that string, and in this case that's false. Bird.ends with checks the other end, and that is true. It ends with OU. Some other string methods. Formatting. The format method works like a fill in the blank, where the blanks are indicated by the curly braces. The items listed inside the round parentheses at the end of the statement are there to fill in the blanks. The number inside the curly braces tells it which of the items in the fill in the blank list to use to fill the blanks. And it uses zero-based indexing. This example is a bit unusual because it asks for poly before it asks for the number 2. In other words, it asks for curly braces 1 earlier in the sentence than it asks for curly braces 0. You can do this the other way around as well. It will just go, so since I put the 1 first, it uses the 1th, so it's 0, 1, uses poly as the first thing it fills in, and then where the 0 is, it's putting the 2. So polybird is 2 feet tall. It's the return value. Usually you want to store this return value in a variable or maybe print it out. This particular example fills in the blanks and returns the string that says polybird is 2 feet tall. You could use an assignment statement to store this sentence for use later. There are many different ways to do string formatting in Python. Just keep in mind that the main idea of string formatting is to create a value that combines string literals, the things inside the quotes, with variables, and the variables themselves don't have to be string data type. So if you have a string literal that you want to combine with a string variable, you need to think of string formatting. Because string formatting is so useful, we are going to revisit this in a few minutes. If you take rjust, it stands for right to justify, and pass in a 6, that's the number of spaces within which you want to justify the string. It'll move ABC to the right 3 spaces and give you blank space in the front. We already discussed the z-fill, which fills up with zeros for the length of the string that you specify. Stripping. So this one we'll use a lot. Stripping has to do with getting white space off of a string. Why would you ever need to do that? Some of the strings that you bring in from your data will have carriage returns or tabs embedded in them, and you want to get rid of them. This strip method peels off any white space that's found on either end. When we say white space, we need blanks, just like we mean when we are talking about the white space in an IDE. It has, you can turn on white space and it shows you dots where each of the spaces are. So this one peeled off all of the white space that was on both sides of this string. The L strip, if you want to only peel off what's at the beginning of the string, or the R strip, left and right. The right strip strips off any white space at the end of the string. The encoding, there's one called encode and one called decode. Here's an example for encoding. This came up when people were using Excel or Microsoft to source their data. So they're reading the Excel with Python, and they get a row, something like this. My string equals a row of data that looks like this. And they're getting an error because of this /U 2020 on the end of the line. That is due to the special character that they've got embedded in the Excel, which is they call it a dagger symbol. Sometimes it's used to superscript things. In order to fix the string so that it can be used in other places, we're going to strip that. We're going to encode this string as ASCII instead of Unicode, which is what it is here. So we say mystring.encode ASCII. We're saying ignore because we're ignoring any errors this throws, because if you don't say ignore, it will throw an error. And that returns the string with the dagger stripped off of the right end. It ends at Q4. Next, replacing. We went over this before. Let's just remind you that you say replace, the object.replace, and the part of the substring that you want to replace with the one that you want to substitute in. So in this case, we start with Parrot likes you and end up with Parrot adores you. Food for thought, how could you use the replace method to remove any spaces? If you're not sure, start a discussion on the message board. Next, splitting and joining. These are very useful when you're dealing with data again. So in this case, we're looking at the numerical value that comes out of the time module. So the time here is 11 in the morning, 11:50 in the morning, 22 seconds, and this many milliseconds. If we want to get those separate parts, we could split the string on colon. When we split the string on colon, we get back the parts 11, 50, 22.0400. Everywhere there was a colon before, that is removed, and we get a comma-separated list of the items that were around the colon. It's not just for colons, it's whatever you pass into the split that'll give you the That'll be the point on which it breaks, and that'll be the thing that it removes. So if we use that nursery rhyme, 1 potato, 2 potato, 3 potato, 4, and split on potato, we'll get 1, 2, 3, 4. Notice the spacing is still there, because there was a space before potato in each of these. One more example, if we split the string Mississippi on the letter I, we would end up with this comma-separated list of items. And I'm using the word list in the sense that Python uses it. It's a Python list. So the join method is the inverse operation. If you take a string, dot join on, pass in the list that you got out of Mississippi, put ack everywhere we saw I, and we get mac, sack, bap, pack, pack, something. In effect, what we've done here is taken out the I, put back in an AC. So we could have done this in one line of code with our dot replace. But usually you don't do them together. What usually happens is you have some data and it's in a list and you'd like to put it in a semicolon separated string, or you have some data and it's a comma separated string, like in CSV, that's what comma separated value files stands for. Then you want to split it on the comma. So we'll see this a lot when we get into reading and writing text files. So here we've taken some data about Raleigh, North Carolina 27695 and joined it on the semicolon, and then the resulting string looks like this. Now we're going to do an interactive window exercise, and the IDEs all have a window for scripting and a window for interactive coding. So single lines of code. The window that's called Python Interpreter in PyScripter is equivalent to the Python Win interactive window. So any IDE that you have will have a interactive window where you can type one line of code and press enter, and the code will run and return what it has there, and it'll show the prompts for you to enter another line of code. Whereas the scripting window is where you save the code. So keep in mind that you cannot copy and paste multiple lines of code into that interactive window. It won't execute multiple lines of code, so in case you're used to the R programming language environment, that's a difference you'll need to become accustomed to. So a few things to keep in mind about the command prompt in Python Win. There must be a space between the prompt and the code. Hitting return takes you to the right spot, but if you backspace, you're going to be in the wrong spot. So if you backspace, like it's here's good. There's a space, 5 plus 9 is 14. Here we said 5 plus 9 is 14, but we backspaced before that, and then it just gave us a prompt because it didn't execute the code. Python Win has this problem. PyScripter doesn't. It won't allow you. PyScripter restricts you from getting right next to the prompt. So if you're having trouble, it doesn't seem like it's executing your code, just hit return or enter, and the prompt will be placed in the right position to start typing your code again. If you use the print statement in the interactive window, it gives you if you use a print statement on a string, it gives you the string without any quotation marks around it. If you type the variable name in the interactive window, and it will print out the value as well. So I often use this because it's faster. You don't have to type the word print. And you just notice that it has the quotation marks on the end. But if you've got this variable assigned in your script, and you say print script, print input file, it'll print it out in the command window or the interactive window when your script is running. But if you just say input file in the code that is running in a script, it's not going to print anything out in the interactive window. So we talk about an IDE session because certain things are stored during an IDE session, and a session starts when you open the IDE and ends when you close the IDE. If you open it again, you're starting a new session. It stores the command history for the current session. You can use Control up arrow or up arrow in Python Win and PyScripter or other IDEs to roll up to previous commands instead of having to type them out again. Look out for your window focus. If you are working on a script and then working in the interactive window, make sure you save the script window and submit that. Don't submit a window where you've been working in the interactive window. We don't want to see command prompts in the Python scripts that you submit. If you try to run those, they won't run. It'll give you a syntax error. So by focus, you can just click on the window that you want to have the focus in. One more thing, a variable that's assigned a value during the session, the current session, keeps that value until another value has been assigned. For example, if I set x equal to 5, x is 5, and I have a script. I can run this script and it prints 25 because we've squared x. If I close this, end this current session, open this again, I can open my same script again, and let me tile the windows. Try to run the script again. I get a name error because the x is not defined. The script ran before because x was defined during our current session, but it won't run now because the session has ended and that assignment has been removed from memory. This is a little bit of a pitfall sometimes with writing code, and then be sure to close and open your session and run it fresh before you submit a script. Let's do an in-class exercise, which involves, you can go over to the in-class webpage, and we've got this set of commands here and a set of questions that you'll be asked to answer at the end of it. So this is using the operations and some of the methods that we talked about today. Go ahead and open your browser to the in-class page. Let's just go to in-class day 2, and that brings us up to this page. And we have these series of commands to be placed in the interactive window. So again, try to predict what will happen when what will be printed out, what will be the output when you do these commands, and pay attention so that you can answer these questions at the end. So you may have discovered that if you copy and paste directly from the web page, you're going to have some problems. So let's look at what just happened there. We pasted x equals GIS, so we should be assigning it a value, but it doesn't think x is defined. It says name error, name x is not defined when we try to use that value. So let's try and paste it again. Notice that it's showing up kind of greenish blue. That's because it's on the next line. And so for somehow when I copied it, I grabbed a carriage return as well. So now if I hit return, it gives me another syntax error because it's pointing at the quotation marks. So this is because the encoding of quotation marks in the HTML is different from the encoding in Python. So notice how this turned string colored. So now let's try our next line of code. And that gives us G because that's indexing the first item in the first character in the string. If we say x equal x index 3, we get an error. That's because if you try to index past the end of the string, you're going to get an index error. You can only go 0, 1, or 2 in this case. Why does this say false? Well, there is an S in X, but it's an uppercase X. It's case sensitive. What's the length of X? 3. Now we're setting up another variable. And then we do an assignment statement. Notice it doesn't matter if you have how many spaces you have around the plus sign. Now when we call the built-in length function on X, it should give us a different value. It's going to be GIS plus rules, so 3 plus 5. Next, we're doing the S in X statement again. I use Control up arrow to get to that. And now it says true because we have that lowercase s. The next operation is called, do you remember what this is called? Slicing. So this is going to give us the 0 and 1 character. The 2 is not included. So now X is GIS rules, so it'll be GI. How about same thing? That's because if you don't put a number in either side of this, it defaults to the end. So this will start at the beginning of the word and go up through character 1. What about this one? What will that return? Yeah, an S. Because we're X right now is GIS rules, so we're 0, 1, 2. Oops. Now this one is a fancy slice. We just said that if you don't put anything before the colon, you start at the beginning. But what does a negative number in the second spot do? So it took off the last 4. So it counts from the end starting at 1. X of 3 now is valid because so we got an index error when we tried that before, but that was because our string was shorter. Now we have 8 characters, so we can say 0, 1, 2, 3, which is R. We just looked at X, so we don't have to repeat that. I'm not sure why I'm scrolling through our choices here. We have GIS rules in all lowercase. So GIS rules was, the first 3 were upper before, and now what is X? It's the same. That is because when you do a string operation, a string method, it doesn't change the value of the string. It returns, like it's the butler, goes out and brings back all lowercase GIS rules and gives it to you, but it keeps its own original value. Now here I'm at the wrong spot. I can just space out 1 space. Y dot starts with RU. Do you think what do you think this is doing? It's going to return a Boolean, which means true or false. And what it's doing is asking, does y start with ru? The answer is yes, it does. That's true. Now if we print x comma y, it doesn't matter if there's a space or not. Just want to make a point. We get GIS rules. And then if we print x plus y, we get GIS rules. In this case, the comma puts a space wherever it appears. So this is x, the first string is x rules, and the second string is rules. So it puts a space in between those. If you use plus sign instead, it concatenates them directly without any space. Okay, another variable. These quotation marks were encoded differently, so they're working. And the final one we're going to do is another string method called zfill. And it takes an argument, a numerical argument, and look what it did. Let's try saving that in a variable. So we have val equals, and then if we say len of val, that should give you a clue as to what it's doing. So it fills it up. It fills up the number with zeros on the left for however many spaces that you have specified. Not the number of zeros, but this for a total length of the number of spaces that you've specified. So that can be useful if you're writing to a file that you have numerical data and you need to write to a file where it has a consistent length. So let's go back to our questions. So why does x3 give us an error the first time but not the second? There's no fourth character the first time, but there is the second time. What does the Python keyword in do? Does case matter? We saw this example s in x, and case does matter, and it says true or false depending on whether the substring is in the string. How can you change the statement x equals x plus y to print GIS rules? Well, you could put a comma in between x and y like we saw in our other example, or you could put a quotation mark with a space, a string with one space in it, and concatenate that. What's the difference between these three? We have a slice, and a index. The slicing for the first two is going to give us the same result. The indexing is going to give us a single character, and these two are going to give us two characters. We saw that this -4 counts from the back and takes those characters off. If it doesn't have enough characters to count 4 in, it just returns an empty string. So if you have ABC, it'll return ... Lower made a lowercase version, but the original value is unchanged, and the difference between those two is it puts a space in between. So the take-home messages from this exercise are: indexing is zero-based. Indexing throws an index error exception if the index that's requested is greater than n-1, where n is the length of the string. Indexing and slicing look a lot alike, but the slicing uses the colon and optionally a number at both ends. A start and end index. But it always uses the colon. Spaces must be inserted explicitly in concatenation, or things will just be put right next to each other. String methods do not alter the string itself. Instead, they return a value. Like we had all lowercase GIS rules return, but our GIS was still capitalized in the original variable. Lastly is, if you're not sure what a method does, try an example in the interactive window, or look at the string method documentation. Usually one or the other or both will be helpful to figure that out. A lot of them are named intuitively. Here are 3 approaches for printing strings and numbers together in one statement. If we have string variable and a numerical variable that we want to print in one statement, like the data file and FID we have here, you can use a comma, and that'll put that space in between the two. You can use concatenation, and that won't put any spaces in between the string literals and the variables that you have. So here we have the first FID in, that has spaces in it because that already had spaces in the literal, and then counties comes right after that, smack after it, because we didn't put a extra space in there for it. Now, another alternative is to use, I should also point out that in this we had to cast. We had to cast the string FID. We had to cast the numerical value FID to strings so that we could concatenate, because otherwise it gets all confused. It doesn't know whether to add or concatenate. It doesn't do anything. The string formatting is another method which we'll use a lot in the class, because that allows you to write pretty much what you want to write in normal language and just put placeholders where you're going to fill in the variables. So let's look at string formatting a little bit more closely. We had this example on a previous slide. You can use casting and concatenation and put spaces in where you want, or you can use the string formatting, which puts a placeholder, a space, a placeholder, and then ends the quote. Then you say dot format and put the variables that you want to pass in, that you want the values to appear into these spots. So the curly braces with numbers inside are placeholders in the string literal, and you place the things that you want to insert into the string comma separated inside the parentheses. Comma separated inside the parentheses. So look at this example. X equals 5.3398. Unit equals miles. In file equals tree.shape. So we have 2 strings and a float that we want to put and make the sentence. File tree shape was buffered with a 5.34 mile buffer. So how do we do that? We want to put the variable for the file name here, the variable for the unit, for the numerical value of the unit here, and then the unit there. So we have input would go in the 0th position, X would go in the 1th position, and unit would go in the 2th position. Notice that the indexing starts at 0, just like with the string indexing. There's something a little special in that second one, which is the colon point 2F, and that you can put in if you want to specify the number of decimal places that you want to show. So that'll give you the 5.34, it rounds it up, it rounds it to that place, and that'll put that in for you. If we didn't have the colon point 2F, this would just appear as 5.3398. We can also use formatting for other data types. This is a list, which will be talking about soon. And we can simply put A in here and it prints out just like it was when we started. So use string formatting to form print statements or to form string variables that you need to compose with using variable values. So that wraps up our discussion of numbers and strings for this lecture. We talked about integer, floats, and string data types, a little bit about complex and long numbers as well. Remember about integer division. You can use the casting to float, and when you cast a float, the integer division will not occur. So if you cast either the numerator or the denominator to a float, then it will use floating point division and it won't truncate your values. We differentiated between a string literal and a string variable. The string literal has the quotation marks in it, and the variable is pointing to something that has the quotation marks around it. With indexing, slicing, concatenation, and length, and the membership in keyword, we had some operations that we can do on strings. We looked at line continuation, escape sequences, raw and Unicode strings, and finally we discussed string formatting. Next time we'll talk about lists and tuples. There are some additional slides with related topics. If you'd like more information about commas versus concatenation, how formatting used to be done, string formatting, there's an old school style that you may see in some found scripts that you want to use that you may want to be familiar with, which uses a % instead of the dot format string method. Then escaping quotation marks. Just want to reinforce that the dot format method is just a method like dot lower, dot capitalize, dot replace that you can put on the end of a string. It looks a little weird because you're putting it on the end of a string literal, but it has arguments just like the replace method has the thing that you're going to replace and the thing that you replace it with. It's a string method following the same format. And that ends the lecture. Thank you so much.